So this set of notes is looking at getting the trig functions from the graphs. So you're given a graph of the function and you're going to be coming up with the four components. The A, which is our vertical expansion and flip. B, which is our horizontal compression, expansion, and horizontal flip. Our P is our horizontal shift, which represents the starting point of our graph. And the Q is our vertical shift, which represents the middle of the graph. So I've shown it here. So P for cosine and sine differ. So we have to be careful of which one we use. Ideally, we want to use P because we're often given the max and min points of the curve. So there are some generalizations here, which we went over in the last set of notes. The A value can be found as a distance or length by subtraction. When we subtract, we get length between y positions. A divided by 2 gives you y max minus y min, gives us a distance between y and max, and y min and max, and we want the half that distance. B, it relates to the period. Okay, so we want to find the period. We know that the period and t are related. The b and the t are related with this formula. And it's essentially the same formula. You can intershift those, and we can find the period by doing this. We take the x of our max or min, the position. Since period is a length, we subtract to get the length, and the period is not going to have a direction, so we just put the absolute value around that, and we want the distance from the max to the min, and we want to double it, because if you take a look at our graph, from the max to the min represents exactly 1/2 period, or 2 quadrants. Okay. Our Q value, which relates to our vertical shift, so when we find the amplitude, we want a length, so we subtract. Q value is a position, so we want to add those y coordinates, add them together and divide by 2, which gives us the average between the high point and low point, which gives us the middle point. P relates to horizontal shift, and it differs depending on whether they're talking about sine or cos. So again, if we're talking about sine, we're talking about the position in here. Okay, we'll talk about cos, we talk about that position here. Essentially, there's lots of positions we could use, and they all are related by 1 quadrant or 1/4 period. Okay, so let's take a look at the graph here. We've been given a point, the minimum point's at -2 pi over 3, the maximum's at 5 pi over 3 and 8. So if I just get you a quick graph here, let's say that that's pi over 3 here, 5 pi over 3 maybe somewhere around here. We know that we have a min at -2, max at +8, and it goes through 2 quadrants. Okay, to go from the min to the max. Okay, so what we want are our different parts of this. So I'll do this in different colors for the first one. So the A value represents our amplitude. So if we want the amplitude, we're going to take the position y and subtract the position 2 and divide by 2. Okay, that gives us the distance between top and bottom. Okay, and then we will divide that by 2 to give us the amplitude. So halfway between 8 and -2 is going to be 3. Okay, so our amplitude, oops, sorry, that's not halfway. We're doing the difference. So halfway is going to be 8 plus 2 divided by 2 is 5, so our amplitude is 5. Okay, so that represents the distance from middle to there. Okay, we'll find the middle. We want to find that vertical middle, which is our Q value. Our Q value is going to be the average of those 2 points. Okay, so we're going to end up with a Q value of y equals 3. Okay, we want to find our period and our shift. So the period we'll do first because it's a little bit easier. The period t is calculated. We know that this distance from here to here represents half of our period. The distance, so we subtract 5 pi over 3 minus pi over 3. That's a distance. And then we want to double that distance to get the entire period, because that only represents 2 quadrants, so we want 4 quadrants, so we have to double it. So the distance between is going to be 4 pi over 3. We double that distance, it's 8 pi over 3. We want the graph, the function, so we need to calculate b as well. So then if I plug that into my 2 pi divided by our period, we're going to end up with 3 over 4 when I simplify that fraction. The last thing then is we want the p value. We want the horizontal shift. The easiest way to get that horizontal shift is to take a look at that point there. It's been shifted to the right for the cosine graph, and that represents the start of a cosine graph. Okay, now that here we could use as the start of the sine graph. Okay, we can use that point there and use an upside down cosine graph. There's lots of different possibilities here. I'm going to just stick with the easiest one and say that we've shifted 5 pi over 3 to the start of a cosine graph. So the p-value is 5 pi over 3, and this is specifically for the cosine function. Now that I have all the parts, I'm going to put it all together and write the y equals equation for this. The amplitude is 5. So let me just write this in here. Sine bracket. Okay, so we're going to find the amplitude. The amplitude is 5, which we got there. We know that the b value is going to be 3 over 4. Okay, that's what we got over here. Okay, from our v. The horizontal shift was our cosine. Oops, so we use a cosine, so I better change that. The cosine was 5 pi over 3. And we're going to change that. I forgot that we're using cosine, which is what we want to use. So this is going to be cosine. There we go. And then the last component is our vertical shift. Okay, our vertical shift is, the middle line is plus 3. So there it is. There's our function, our y equals function for this.